Welcome to the second module of the course. The second module is about giving you an introduction to 3D printing. What is 3D printing? And in the second module, we will be learning about the very basic definition of 3D printing or additive manufacturing. Now, again, I would like to repeat myself that 3D printing and additive manufacturing are two interchangeably used words. I will also be using both the words 3D printing and additive manufacturing, but they refer to the same thing, same technology. Now, then we will be learning about why do we need 3D printing? What is the advantage of using 3D printing? And then we will talk about the various 3D printing technologies classified by ASTM based on the nature of their process. Then we will be learning about the major additive manufacturing or 3D printing techniques which are being used in the commercial market. How do they work? What is their working principle? And what are the kind of materials that they deal with? So let's get started with the section 1 of module 2. Uh, Additive manufacturing is one of the process where you don't remove the material to give the desired shape. Now, right now, what you can see on your screen, this is a schematic representation of subtractive manufacturing, where you take a block of material, start removing the, start cutting material away from the block based on the program generated by the CAD model, 3D design CAD data that has been given to the machine. And finally, you end up in the desired shape or the object that you wanted to produce. But this has happened by removing material. Now, when we talk about additive manufacturing, the same shape or the same object will be achieved, but not by removing material, instead adding material layer by layer. So additive manufacturing is the process of creating an object by building it one layer at a time. Whereas in subtractive, material is removed from a large block or a big block of material. Uh, After removing the material using a cutting tool or a machining tool, the object will be remaining to its final shape. In this schematic, you can clearly see that a raw material of block is taken. Then that raw material of block is undergoing a machining operation, and the material is removed based on the machining operations input. And what you achieve is the final product, which in this case has been represented by the spherical shape. So the what machining is doing, it is converting a block of solid block of material to a spherical desired shape of material by removing material. And the material that has been removed in order to desire the final to get the final product, that is the waste material. Now the scrap rate is usually very high in subtractive manufacturing, whereas in additive, what we do is that we start with a spool of material, wire of material, or material can be in powdered form. Both inputs are it depends on the process. What is the process? Based on that, the input material is decided. Then we start the printing process using that input raw material. Once the printing process is done, that means that the material is added layer by layer, then we reach the final product, the desired shape that we wanted to create. Now the advantage here is that the waste material that we have created is very less as compared to the final product, because you have used the amount of material precisely as much as it is required to create the object, and little bit of wastage. Whereas in subtractive, you have removed a large amount of material. Whatever was not required, you had to remove that, because you are starting from a fixed shape and you have to reach a desired shape. Now, uh, we will understand additive first, but in order to understand additive, first we need to understand what is subtractive manufacturing. And for that, I'm now going to play a video. In this video, you will see that how subtractive machining process gives shape using cutting operation or material removal operation from a solid block. So as you can see that the solid block has been taken, mounted on the CNC machining center or a milling machine, and a cutting tool which has been designed to remove material at a very high speed and with minimum defects is rotating at a high RPM, which is attached to the spindle head of the CNC machine, and it is removing material as per the input given to the machine. Now, slowly, it will keep removing material in multiple steps or depending on the strategy, how the operator has made the program. But based on the program, it will keep on removing material, and ultimately it will try to attain the shape that has been given as the target shape to be obtained after the machining process. And for this also we need to upload the 3D CAD model, and we also need the 2D drawings in order to decide upon the right tolerances to be produced during machining. So this is subtractive machining, and you can see that using different set of cutting tools and different cutting operations with different cutting parameters, the final desired shape is obtained. Now again we will see a very short video of an additive manufacturing process, where we will see how material is being added. Since the subtractive machining process was for a metal, the additive manufacturing process also that I'm going to show you is for metal. Now in this video you can see that the material which is raw material in form of powder, metal powder particles, is coming from a laser head, and from the same laser head laser is also coming out. Now this laser is giving the energy to melt the powder particles and deposit it in a specific manner, and as soon as it solidifies, it is solidifying in the shape of the uh, data that was given for the 3D printing operation. So it is you can very clearly see that the laser head is only depositing material in the area where the data has been given to the machine. Now this data will be given by slicing of the 3D CAD model which you want to produce. But the advantage here is that you only need to deposit material which is uh, required to be there, and slightly some extra that we will understand what are the requirements. Yeah, so now we understood, okay, how what is additive, what is subtractive, how both of them are varying from each other in terms of their working principle. Now we need to understand why do we need additive manufacturing. So there is a very interesting example of additive manufacturing case study. This is a BMW chassis, a BMW two-wheeler bike. We all know that BMW bikes are known for their high performance. And in automotive, performance to weight ratio is very important. They either need to increase the performance or they need to reduce the weight. So this performance to weight ratio that we are talking about, uh, a large weight of the vehicle is contributed by the chassis of the vehicle. And in this case, they tried producing a 3D printed chassis because they wanted to reduce the weight of the chassis. And this particular case, if you go and explore further, you'll be able to find that around 40 to 50% of the weight of chassis was decreased using a unique design technique called as topology optimization. That is why this is looking like that. Now, topology optimization is something which has come up with additive manufacturing, and it basically mimics the natural designs in order to create a structural design. So that is why many of us say that additive manufacturing is the natural way of creating things. And like this, we can create more complex designs. And more complex designs will help us in improving the performance of the component or the subsystem that we are designing for. It also leaves us with less waste material, and inherently it is much faster as compared to the other conventional manufacturing techniques such as subtractive or forming, and there is no tool required in order to make uh, components through additive manufacturing. So making a component through additive manufacturing gives us various advantages, whether it be in terms of lead time, or whether it be in terms of higher design complexity. So all of this can be leveraged if we choose additive manufacturing as the final route of manufacturing for any component. Now, this is a very interesting comparison. This comparison basically, when you see the blue curve, that is your conventional production, and when you see the peach curve, that is your 3D printing line. Now, as the design complexity increases, the cost of manufacturing a component increases as per conventional production. Whereas in 3D printing, with the complexity, there will be an increase in cost, but the increase will be very minimal as compared to conventional process. So if you have really high complex design components, then conventional manufacturing might end up having being more costlier as compared to 3D printing. So if we are in this zone, we can choose 3D printing as one of the preferable way. Then we have the second graph where you see cost versus number of components. Now, when the number of components increase, conventional manufacturing technique allow us to reduce the cost per component. Whereas in 3D printing, the cost will decrease, but again, the decrease in cost is very minimal if the volume increases. So if you are having low volume of certain type of components, then you might up ending paying more amount through conventional process for manufacturing and less through 3D printing. So when we are in this region, when it comes to number of components, 3D printing is a more suitable way to suggest for manufacturing. Now, since we have understood about additive and traditional manufacturing process, let's try to just plot down the comparison. Okay, how do they compare when it comes to few of these entities, like production time? So additive manufacturing is usually having less production time as compared to the traditional manufacturing process. Material wastage is definitely less in additive manufacturing, again, as compared to the traditional manufacturing process. You can allow for easy customization in additive manufacturing, because if I'm building 10 components in a single build in additive manufacturing, all those 10 components can have different kind of designs. Whereas in traditional manufacturing, it is difficult to customize, because when we try to customize each and every design program has to be generated separately, and there is some setup time involved in changing from one design to another. It is definitely cheaper to make prototypes because there are no tools involved and you are using less amount of material and the time taken is less. Whereas traditional manufacturing processes prove out to be expensive when it comes to making prototypes. Then the labor cost is very much reduced when it comes to additive manufacturing, because there is less human labor involved. And as traditional manufacturing suggests, it's the traditional way of manufacturing, so labor costs are more. So this was about additive and subtractive. So I hope you understood what is additive. Now, from the next section of this module, we will try to understand in detail what are the different kind of additive manufacturing processes that we will look into once we start uh, getting deeper into the manufacturing realm. Thank you.